Recall that previously we had downloaded the correlation matrix and other statistics from these four mutual funds that represent large company stocks, SPY, small company stocks, corporate bonds, and government bonds. And so this is the stats file that we downloaded after running the Portfolio1 notebook in Python. So I'm going to save this off as a file called Portfolio1. Just to save it as a different name. Now, the problem that we're going to try to solve here is an investor has $10,000 to invest for 1 year, and they have these four potential investments. So we're going to enter in this worksheet a beginning investment, and we'll enter $10,000. Now, the problem really then, if they invest $10,000, is to determine the portfolio weights. And so what we'll do here, just to have starting values, is enter 25% for each investment, which means that the total is the sum of those, and the total should equal 1 or 100%. Now, what we need to do is then come up with the allocation of the $10,000. So we need to multiply the $10,000 times each of the investment allocations, and we need to put an absolute reference on the column B so that this beginning investment is spread over the four portfolio weights. We'll enter a sum out here in the total column just to make sure that the allocation equals the beginning investment. Now, we're going to use geometric Brownian motion to simulate the ending prices after 1 year for these four investments because we have the GBM parameters estimated here. So what we need to do is to just have a random variable we'll call Z, and in at risk, that's going to be a standard normal random variable. Which is normal, mean 0, and then standard deviation 1. So the default seems to come up 10, but we'll change that to 1. And then we'll copy that over here to the other investments. Now, the time increment for the simulation is going to be 1 for 1 year. And then we'll simulate the ending price. The ending price is going to be simulated with geometric Brownian motion. And so here's what the ending price will look like. It will be the current price of the stock and then mu minus sigma squared over 2 times the delta of the simulation, which is here on row 15. And then the second term is sigma hat times the square root of delta. Delta is the time for the simulation. It's on line 15. And then times z, which is the random part. That's the standard normal random variable. So here's the ending price. In this case, it's calculated for SPY, but we'll be able to copy it over for all the other stocks. So that is the simulated ending price. And then we're going to actually calculate the shares purchased. And so the shares purchased will be the allocation to each mutual fund divided by its current price. Now what we want to do is then simulate the ending value. And the ending value will be the shares purchased times the ending price. And then we'll total that amount over here to the right. And we'll make this total an output in at risk. Now, we're not quite ready to simulate this model because we need to utilize the correlations between each of the investments, and so we'll cover that in the next video.